All right, on the front of this worksheet, we did a couple of these in class together, and then you were supposed to do this bottom reflect, rotate, translate in preparation for the quiz on Friday. So let's go back through these. You can fast forward if you do already have some of these done. So here, when they have a 3 marked, it means those are 2 congruent sides, right? So we're going to say something like side QR is congruent to side SR, side QP is congruent to side SP, and then this reflexive side, PR, is congruent to itself. So this is congruent by side, side, side. So triangle QPR is congruent to side triangle SPR. You have to say it in this corresponding order where the same corresponding parts go in the same places. All right, next one has side EB is congruent to side ED. Side CE is congruent to side AE, and angle BEA is congruent to angle DEC. So we have congruency by side, angle, side. All right, let's go write the triangle name. Triangle BAE is congruent to triangle DCE. Okay, pause the video at this point and try some on your own and make sure you know how to do these. All right, angle, angle, side. This is going to work as well because of this reflexive side right here. So side YW is congruent to itself. Angle X is congruent to angle Z. Angle XWY is congruent to angle ZYW. Notice that we could say these letters in different orders, and there's like a couple different variations. This is going to be congruent by angle, angle, side, or side, angle, angle. Those are both work depending on which way you wrote it. And so triangle YXW is congruent to triangle WZY. The next one does not have enough for congruency. It only has an angle and a side. Oops, not angle AB, side AB. And so just a side and just an angle is not enough for congruency. Next one has a little sneaky reflexive side in there again. Side QS is equal to itself. And then we've got angle RQS is congruent to angle PSQ. And angle SQR is congruent to angle QSP. So the triangles are congruent by angle, side, angle. And so QSR and SQP. Let me double check that. Q had 2 marks, S had 1 mark, no mark. So we go S, 2 mark, 1 mark, no mark. Okay, good. Done. Last, we see that this side is equal to this side. We see this angle is equal to this angle. We see this side is equal to this side, but ASS is not enough. So this is kind of a trick question where you're supposed to know that these vertical angles are also congruent. So trick question. Sorry guys, that one's kind of mean. So for the vertical angles, we're going to use angle, angle, side to prove this. So we're going to say that HK is congruent to MK. HK and MK. We're going to say that angle J is congruent to angle L. And then we're going to say that angle HKJ, so this guy right here, is congruent to angle MKL. We have to use a 3-letter name when they're a shared vertex. And so the triangles are congruent by AAS or SAA. Sorry, hang on, what did I just do? Sorry, guys. Angle, angle, side. Did I do two angles? Two angles and one side. Yes. Okay. HKJ. HKJ goes out, in, out, is going to be congruent to MKL. Triangle, MKL. Okay, how'd you do? Now pause this next part, try it, and then go ahead and see if you got it. I'm going to start with the translation first. Translate, so vertex A is at the origin. So point B is going to go down 1, 2, 3, 4, and back 3. So that, hang on, which vertex is at the origin? Sorry, vertex A. Just kidding. So down 1, 2, 3, 4, 5, 6, 7, 8, and back 1. So this is going to be an X minus 1, Y minus 8 movement because I'm going back 1, down 8 with every point. So this is going to become my A triple prime. B is going to go down 8 and back 1. And C is going to go down 8 and back 1. Grab your straight edge and connect those dots. A rigid transformation should create a triangle of the same shape and size as your original. Make sure you have all your labels. New dots are going to be at 0, 0. B is at 2, negative 4. C is at 6, negative 2. All right, I'm going to jump up to reflect next. It wants us to reflect across the y-axis. And the y-axis is this guy right here. So I'm going back to the original triangle to reflect. So A is 1 away from the axis. So A prime is going to be 1 away in the other direction. C is 1, 2, 3, 4, 5, 6, 7 away. 7 away. C prime. B is 1, 2, 3, 1, 2, 3. B prime. Go ahead and grab your straight edge. Connect it. When you do a rigid transformation, you should have a triangle of the same shape and size. All right, new vertices for that one are at back 1, up 8. B is at back 1, 2, 3, up 4. C and up 6. Notice how it just made a negative of all the original points when we reflected over the y-axis. Kind of interesting. Okay, rotating 180. Instead of doing a 90-degree rotation, like all of the ones we've practiced so far, we're doing a 180. A 90-degree, we need slopes and flipping the slopes. For 180, it needs to be on the same line. Can you picture a 180-degree line? And so same line means same slope. So let's go look. We want to do this around the origin. So right here, if this segment goes from A to B is a slope of up 1, 2, 3, 4 over 3, we're just going to continue it in the same direction. So down 1, 2, 3, 4, back 3. There's my new point B, double prime. Point A is up 1, 2, 3, 4, 5, 6, 7, 8 over 1. So keeping that on the same slope, there's my point A. And then point C is up 1, 2, 3, 4, 5, 6. Is that over 7? 1, 2, 3, 4, 5, 6 over 1, 2. Over 7. So we continue that. So up 6 over 7, up 6 over 7, same slope. This is going to be your C double prime. Go ahead and grab your straight edge. Connect your triangle. Rigid transformations should create same size and shape. There's my rotate 180, same slope. We're never going to test on a rotate 180. I just wanted you to see one that did have the same slope. Okay, let's go put those coordinate points in there. New coordinate A, is it back 1, down 8? New coordinate B, is it back 1, 2, 3, down 4? And new coordinate C, is it down 7, down 6? Look at the change in the original points when we rotated 180. See how they just became negatives of everything? Kind of interesting. Okay, that's it. How'd you do?